Start.
Hello everyone, this is assignment group 3 and our assignment is on data pre-processing. So data pre-processing is a crucial step in machine learning that involves transforming of data and organizing it, draw data into format like suitable for training the machine learning models. And why do we need data pre-processing? So it need to improve the data quality and dealing with the missing values, normalizing and scaling the data, healing the outliners, and dimensionality reduction. So from the next slide, my friend Darun will continue it. Thank you.
The steps in the data pre-processing are first we take the input like the data from the user, and then like we do the data pre-processing like database merging, encoding categorical variables, data scaling and normalizing, inputting the missing values, train testing the splits, etc. And then after we do the exploratory data analysis like data visualization, anything else, and then we build the model for the outputs like model evaluation, model training, hyperparameter training, and model selection. And then after we give the output from the input we have taken for the user desired sets. Can you move to the next slide, please? Yeah, the data set description, ID, a unique identifier for each individual, status, the marital status of the individuals, gender, yearly income, children, education, occupation, house owner, caste, commute distance, region, age, bike bias, latitude, longitude, city, zip code, etc. These are all the ID, like the main things we are focusing on. From here, my friend will be continuing.
Right. So this is the data which we have with the unique IDs and the marital status and the genders, along with this yearly incomes. So here we took like 9 data sets, and here the package. First one is a Panda. Pandas is a powerful data manipulation and analysis library built on top of NumPy. It provides the data structures and functions for handling structured data like tables, spreadsheets, and NumPy. NumPy is fundamental library for numerical computing in Python. It provides support for large multi-dimensional arrays and matrices along with a wide range of mathematical functions to operate these arrays efficiently. From this, my friend will continue.
Yeah, my name is Akhil, so I'm continuing from here. So I've taken the Matplotlib. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python, and it provides a wide range of plotting functions to create various types of charts and graphs. So Matplotlib is an essential for creating publication quality plots and data visualizations in scientific research and data and analysis and presentation. So here the Seaborn is a data visualization library based on Matplotlib. It provides a high level interface for creating aesthetically pleasing and informative statical graphics. So here a Seaborn is a commonly used in data analysis, so statical moderating and a machine learning to quickly generate informative and a visually appearing a visualization. So from here, my friend Sravya will take over.
Yes, Trevor, you can continue.
Can you please unmute yourself first?
Here, the step 1 is importing the packages, and step 2 is the data cleaning, and step 3 is the data visualization. Here, we have imported the Pandas library and NumPy, Matplot, and Seaborn, as all my friends have discussed earlier. And then we have imported the CSV format data set into this. Then we are retrieving the data by using data.head. Here we can see all the columns like ID and marginal status, gender, yearly income, children, education, occupation, homeowners, cars, region, age, and etc. And when it comes to the data set description, this data set appears to contain information about individuals, including their demographics, financial status, and geographic location, depending on our analysis goals. You can see this data to perform various types of analysis, such as demographic profiling, customer segmentation, or predictive modeling. Here, the ID is the unique identification of the customer, and the marginal status and the gender, yearly income, children, education, occupation, homeowner, cars, commune, distance, age, and the latitude and the longitude city also represents the customer location and the target feature. When it comes to the dimensions of the data set, here we can see the output. It's 10,000, 18. And then to get the information of the data set, here you can see all the column and the non-null count and the data type. And it shows like object, int, and float according to their attributes. Can you please scroll up? When it comes to data cleaning, we are cleaning the missing values. Here we can see all the missing values, the region, everything. This is to know how many missing values are there. Here the code represents the latitude, longitude, city, zip code, and the country. These are the features which contains the missing values. Here we can see the percentages of latitude, longitude, city, zip code, and the country. And here we can see the percentage of the missing values. And there are a lot of missing values, highly difficult to do imputation. If we do imputation, it's almost duplicated. This may affect our accuracy. To get the category count, these are the subcategories in children. One is the education, and then occupation, homeowner, and the compute distance. This shows the output. To check whether the data contains duplicate values or not, here we can see the output 0. No duplicate values in the data. To delete the columns and everything. Again, checking whether the data contains missing values or not. Here we can see the output and then the missing data. From the above output, we can see the missing values, which are the latitude and longitude columns, filling null values using KNN imputer. KNN imputer is a data imputation technique used to fill in missing values in a data set using the k-nearest algorithm. Here we are using the sklearn algorithm. From that, we are getting the output like latitude and longitude. And here we are dropping the data frame like latitude and longitude, where the axis is equals to 1 and the in place is equals to true. Again, we are checking the dimensions of the data set. Here we can see the same output here also. And here we are checking the head, like only the first 5 columns, rows. And then from here, my friend will continue. As you can see the above result, there are no missing data in the data set. And then we'll continue the data visualization, which will be continued by my friend.
All right. Thank you, Savia. Now I will continue the outlet detection. The outlet detection is nothing but we have to analyze the outlet detection. We miss the columns, we miss the different set of box plots on this. This outlier can shows the different analysis. But suppose we are taking the age of the persons here, and after that we taking the yearly income of the person. The yearly income should not exceed the result of these small circles over there. So we need to enlarge that circles. So with that we use this data. So we can see that there are outliers in the data outliers points that are significantly different from others. Usually high or low values compared to the rest of the data. Okay, outliers handling, we can handle a couple of data sets using through columns and uh, rows. So here we can try again to reduce that yearly income outlier analysis so that you can see the analysis here. After that we do some data head on that. Again we can see the matter status and the yearly income of the peoples. So we got some data set information from there. Um, Biorate analysis is nothing but to get the columns from the data set, like which data sets having a couple of data analysis. We need to check out that. The main aim is the bike buyers who want to buy the bikes using this data set. We're using this data set and we're finding the bike bears how much persons are normally married and singles like that. This analysis you can see the matplotlib uh, uh, matplotlib graph visualization. We can see here married or some and single is more like around 0.10% like that. So from this MO analysis we can see majority are unmarried and singles are less. So these are the females and male genders, like bike bears who are more in that. So we can see the females are more in that, and from the graph we can see that percentage more females only. So here we are cross-checking the all peoples like children's and people, males, females, and older elders, etc. These are the partial college student high schools and graduate high schools. These are, we can see almost fall under the bachelor's degrees categories. So that is the people who wants to decrease their graduate degrees. Then most of the people has zero and one car wanted to buy a bike. So this data set shows the analysis like that and encodings of categorical. Actually, in data pre-processing, we can do that, converting the categorical data to numerical because the model understands only the numerical data. So we can't give the categorical data to the machine learning, I mean, data pre-processing. So we need to convert that categorical data into numerical data so that we can, the machine understands easily and give the best analysis for us using the data sets. Okay, that's why we're changing the categorical data to numerical data. Here you can see the married one, zero, single, zero, zero. These are the numerical data we are adding in our code, and our uh, team members also work with me and they helped me so much in that. And coming to the final drop of the region, we are cross-checking the final analysis. This is the final yearly income, how much the peoples in the data sets they owing the cars and the bikes, those all things here. And that's all from the end. These all the, again we cross-checking the um, all data from the data set. Final data set, it shows that checking the multicollinearly things of persons, the children's how many, and the homeowners and the cars, their age, latitude and longitude of their information, and which regions they are in, mostly Europe and North American countries. These are the images. So finally, I remove the multicolor again, checking VF because VF is nothing but variance inflation factor. It can be checked over the all things variance inflation factors in couple of data sets. So this is the final data pre-processing. We clean the pre-processing and this now the data set is ready to train for machine learning models. These packages, I'm NumPy Pandas, I'm running these packages right now. And now the code is running and we import the CSV file from the downloads folder here. I take in this Excel sheet as a data set. Now I'm running the data sets too. Yeah. Now I'm executing every cell step by step. Columns are 18 and the rows are 1000, 10,000. These are the outputs. These are the data types of different columns. Executing every cell here, step by step. Every output is now coming clearly. I'm checking the null values in longitude and latitude too. And again, dropping the data. Here's the results of null values showing zeros, and the outlier detection right now it shows the visualization of data. The max age is 96 and it shows a yearly income plotting. These are the head two of married males and females of the region. Every cell is running and executing properly. Here are the matter status of visualization married and single. See, you can see the cars is changing the figures. Now encoding of categorical data. Now I'm running this one. These are the data types of European, Northern and Pacific countries mostly. let's say the regions output. These are the head of final outputs, seeing the children's education, age, and all the data sets data right now. These are one more output, a final output. Now I'm checking the multi-count collinearly. And this is the final of checking with VAF. So the output is clear and there is no errors at all runs perfectly here, and every cell is executing properly. That's all from the result output of EDA by Bayer. Thanks for the thing. Thank you guys.